Okay, so this is going to be an Extrema example. Again, only this time it's going to be involving trig functions. Okay, but the same rules apply that we used before for trig functions. So here we go. So we have a trig function right here, and the first thing you're going to want to do is find the critical numbers, and to do that we're going to have to find the derivative of this function. So here we go. F prime x is going to be equal to 2 cosine x, finding the derivative of sine, minus 2 negative sine, so I'm going to make that plus sine of 2x. Okay, from here we know that everything is continuous. There is not anything that we can't put in for our cosine or our sine here in terms of x, so there's no domain restrictions. We're going to set this equal to 0. So the next thing we're going to need to do is simplify this equation right here. Now we can drop down this 2 cosine x because that's already simplified. This sine 2x will simplify to 2 sine x times cosine x. So we're just going to write 4, because it's 2 times 2, times sine x cosine x is equal to 0. Okay, just like before, we need to factor out our greatest common factor here. In this case, it is going to be 2 cosine x. So that will be equal to 1 plus 2 sine of x is equal to 0. Okay, based on zero product property, this has to be 0 or this has to be 0, so we're going to set both of them equal to 0. To solve this one, you should know that cosine x is equal to 0 when x is equal to pi over 2 or 3 pi over 2. Okay, if you go too many times around the unit circle, we'll be out of our interval, so we're just going to stick with these two values. And then right here, our x is going to be equal to 7/6 pi, also 11/6 pi, if you break down this problem. Okay, so here are our critical numbers that we need to test for. So now that we have all the critical numbers, I'm going to test each of them on a number line. Now, rather than testing all the values in between here, it might actually be easier to just graph it and see. So graph it and see where it is for each of these values. So that's what I'll do here. I'll just post the graph and use that graph that's right here to figure all this out. So we have a positive, and then a negative, and then a positive, a negative, and then a positive. Okay, so here we would have a maximum, and then we'd have minimum, maximum, minimum, and then it just keeps going positive from then on. So that means every single one of these critical numbers is also a extrema that we can use. So we also need to use the endpoints, so let's look at every single possible extrema for this problem. Okay, so from here, now I'm going to test each of them. So we know that every single one of these is going to be a min, or a relative min, or a max. That means I know that this is going to be a relative max, relative min, relative max, and relative min. Okay, so these two negative ones are not going to be the absolute mins because we have two smaller mins right here. So this would be an absolute min, as well as this would be an absolute min, because they're both negative 3 over 2. Now the biggest max we have here would be the 3, so then this would be your absolute max. And then this finds all of the extrema. The endpoints don't really matter for this problem in terms of extrema, but you still have to test them just in case. So if you have any questions on the trig extrema, let me know.